Hi everyone. So we just talked about monohybrid crosses, and now we're going to do dihybrid crosses. So monohybrid is when we're only looking at one trait. So mono equals 1. Dihybrid is when we look at two traits at the same time, and it's traits that influence each other. So a lot of you read about Mendel and his work with peas, and he found that pea shape and pea color were connected. So they were most likely found on the same chromosome. So whenever you do a dihybrid cross, you're looking at two traits that influence each other. So in this instance, we're going to use two different letters, S and Y. And we're going to go ahead and distinguish what S means and what Y means. So we're going to say that capital S is dominant, and it's going to equal smooth shape. And it's always important that you write kind of this key on the side so that way you can understand what your letters are representing. So we're going to have lowercase s. This is kind of why I don't like to use s's, is because sometimes it's hard to tell between the capital and the lowercase. So we're going to say lowercase s is wrinkled. Then we're going to say that capital Y is yellow color, and that lowercase y is green. I'm not trying to do your lab work. I'm just trying to show you how to do the cross. So when you set this up, the parent generation is represented with the P. So we're going to go ahead and cross two parents who are heterozygous, meaning that they have the dominant and the lower case trait. So they're carriers of the trait. So we've got SS and YY with the, they've got the dominant and the recessive gene. So what this means is that you have a parent that has the smooth shape and yellow being crossed with the same parent that has smooth shape and yellow. So what ends up happening is that in order to determine the genotypes that you need to put in for the Punnett square, you have to kind of cross them. So what I like to do is I take the first letter and I just match it to the next letter. So I know that I'm going to have S, Y be one of my top portions of my square. I know it's going to be a big square, so I'm just going to go ahead and draw this. So one parent is the possible outcome could be capital S, capital Y. So you just do this, right? You put one on top and one on the side. And then I take the capital S and I distribute it. It's kind of like math, if you've ever done like distributions with math. So now I have another possible genotype as capital S, lowercase y on both sides. So you do this to the top and to the side. Now I have to go through and I have to distribute my next letter. And so I take that lowercase s and I distribute it to that capital Y. Now typically you would write the dominant letter first, but in this instance, I'm just going to go ahead and put lowercase s, capital Y, so that you can see it. I put it there, and then I also put it here. And like I said, you need to kind of over-exaggerate the capitals and the lower cases so that you can tell the difference between these letters. So then I'm going to take that lowercase s and I'm going to distribute it to the next letter, and so you end up with lowercase s, lowercase y, lowercase s, lowercase y. Looks like I overestimated my box a little bit there. So now I'm just going to go ahead and section it off, so that way I can see my outcomes. And what you should end up with is 16 boxes. With a dihybrid cross, it's always going to be 16. And so now you just, kind of like in the monohybrid cross, you just distribute the letters. So, right, like the capital letter goes down to every single box. So capital S, capital S, capital S, capital S. And then write capital Y. So I'm going to keep the Y's and the S's separate. I probably should have made a bigger box. Okay, so now I'm going to bring, you know, the ones that are on the left-hand side across. So we have 2 capital S's and 2 capital Y's. Capital S, lowercase y. Lowercase s, capital Y, and lowercase s, lowercase y. So you always want to write the capital letter first, kind of like I showed you in the monohybrid cross. So I'm going to bring down all my capital S's from the top and all my lowercase y's. Then I'm going to bring across, so you have capital S, lowercase s, lowercase s. And I'm just bringing these from the left-hand side. So now I have this, right, this capital Y from the left-hand side going into this box. So I'm just going to go ahead and list it first for simplicity's sake. Lowercase y, capital Y in the third box, and then 2 lowercase y's. And once again, I apologize for the messy handwriting. I just couldn't find a better way to do this with recording it. Maybe that's something I can work on for next term. All right, so now I'm bringing down the capital Y. Okay, gonna go ahead and bring everything over from the left. So capital S, capital Y, capital S, oh goodness, lowercase y, yep. Okay, see, now I'm getting confused with what I have as capitals and what I have as lowercase. This is a lowercase s, and then 2 capital Y's, lowercase s, lowercase y. And see, I have to double check this because of how I wrote my my capital Y's. Okay, lowercase s, bringing it down, lowercase y, bringing that down. All right, we got capital S, capital Y, capital S, and you can see that these are a little bit more complicated than the monohybrids. So that's why you always have to double check your work. Oh, wow, that's a 5, not exactly an S. Okay. All right, so what you should end up with is this really big ratio. Typically all dihybrid ratios should turn out to be 9 to 3 to 3 to 1. And so what that means is like how many you have of each genotype. And so whenever you look at this, there should be like just, so like the 1 is the 2, like right here. So it's little s, little y, little y. I'm not going to go through and like distribute this for you. Like you can see which ones are the 3s and which ones are the 9s just by looking at the boxes. And it's similar to a monohybrid. You just have to determine by looking at your key, right? So like this one here would be a wrinkled green offspring. And this is just the potential, right? So like it's all a ratio, like every single one of these boxes is a potential outcome. It's not guaranteed that you're going to have 9 kids that come out to be, smooth and yellow. So that's just the difference between monohybrid and dihybrid. So I hope that helped you guys.